Good day, ladies and gentlemen. Today we are looking at financial mathematics in level 4, and we'll be focusing more on depreciation. So this question number 1 says, Mandozela buys a computer for 12,000 rands. The computer depreciates at 18% per annum. We need to calculate the value of the computer in 5 years' time. If the computer depreciates on a straight line basis, and B, if the computer depreciates on the reducing balance basis. So those are the two main techniques of depreciation. Then question number 2 says a TV set was bought in 2019 for 18,000 rands and sold in 2025 for 5,000 rands. Calculate the depreciation rate using the straight line depreciation and reducing balance depreciation. So let's start with number 1A. So number 1A is talking about straight line depreciation. As a level 4 student, when you go to your formula sheet for paper 2, then the formula for straight line depreciation is written as this. If I'm not making a mistake, it should be formula number 26 on your formula sheet, but I'm very sure that that's the formula for straight line depreciation. So whenever you are given a problem like that, all you need to do is pick the right formula from your formula sheet. So your P will always be the original cost of the asset. So you are told that Maths1 buys a computer for 12,000. So that's the original cost, which is your P. So you will just have to put that in the position of P in this formula. So we need this computer to depreciate at 18% per annum. So 18% PA stands for per annum, which is like per year. 18% means 18 on 100. For how many years? 5 years. So our N is 5. So all you need in depreciation is just to know the right formula and you're sorted. So I will now take this through my calculator to make life easy for me. I'll start by checking what is 18 times 5, which is 90. So this is 90 on 100 year, which is 0.9. 1 minus 0.9. So I have my 12,000 in bracket 1 minus 0.9, and that gives me 1,200. So it means after 5 years, that computer that was bought for 12,000 will only have a value of 1,200 rands if it was being depreciated on a straight line basis. So that's how simple it is, guys. So let's look at the B part. We need depreciation now on the reducing balance basis. So it is still part of formula 26 on your formula sheet as a math level 4 student. So all you need to do is know the formula for reducing balance basis, which is now captured like this. So that's the difference between the two formulas. Then we'll repeat the same calculation and we'll be sorted. So if we move on, we'll be seeing that we have our 12,000 there, in bracket 1 minus I, the depreciation rate stays at 18%, the number of years is 5, so we're now going to capture that calculation. So I get 12,000 into 1 minus 18% is 0.18, then raised to the power 5. So this gives me a value of 4,448.88. So that's how simple it is for the first example. So one thing I can pick from there is that in both depreciation methods, the reducing balance method should be the best because your asset loses value slowly. Unlike here, you see an asset that was bought for 12,000 after 5 years is only worth 1,200. But with the reducing balance method, the same asset that was bought for 12,000 after 5 years, you can still sell it for up to 4,448. So if you were to be asked a question like which method of depreciation is better to reduce your asset, you will always settle for reducing balance method because your asset loses value slowly. That's why with straight line we only have 1,200 worth of the asset, but here we've got 4,448. So guys, that's how simple depreciation, straight line and reducing balance is. So when you hear those two statements, straight line depreciation and reducing balance, don't panic. They are quite easy as long as you know this formula, which is given on our formula sheet as formula 26. It's just for you to go there and know that that is straight line depreciation. The other one is reducing balance depreciation. So that done, let's look at the second problem, which I guess should also be easy. It says a TV was bought in 2019 for 18,000 rands and sold in 2025 for 5,000 rands. So we need to calculate the depreciation rate. Depreciation rate means we are looking for I. In this formula's I is called depreciation rate. We need to calculate the depreciation rate using straight line depreciation and using reducing balance depreciation. So again, we are dealing with the same two formulas. So the A part, I start with my straight line depreciation. So A is equal to P in bracket 1 minus I N. So I'm now calculating N. So one thing we must know with depreciation is that P is always a bigger value than A because P represents the original cost of the asset, while A is the cost of the value left in the asset after some number of years that you've used the asset. So since I'm giving two figures, the bigger figure should always go to P because that is the original cost of the asset. So in 2019, the TV was bought for 18,000, that's the original cost, and it is maybe used for a good number of years until 2025. It can now be sold for 500, that means 5,000, it means it will be worth 5,000. So if I have two values like that for depreciation, the bigger one I will capture it under P all the times. The smaller one goes under A. So that is it. Then in bracket I get 1 minus I. My I is what I'm looking for. So the target now is to know N. N is the number of years from 2019 to 2025. If you are struggling with that, you can start from 2019 and you know that from 2019 to 2020 is year 1, 2021, 2022, 23, 24, 25. So that makes it 6 years. So this TV set was used for 6 years and then sold for 5,000. So from here, you can now do our calculation for I. So there are two options. Either you open the bracket on the right first, then you pull like terms together, or you can just divide both sides by 18,000. So I think I'll settle for dividing both sides by 18,000. So this will tell me that 5,000 divided by 18,000 is equal to 1 minus 6I, because if I divide the right side by 18,000, the 18,000 will be cancelled. So I will just check what is 5,000 divided by 18,000. That gives me 0.2777. So I'm getting 0.27778 is equal to 1 minus 6I. So since I'm looking for I, which is the depreciation rate, I will carry 6 to the left to become positive. Then this number will come to the right to become negative. So this takes me to 6I is equal to 1 minus 0.2778. So what is that? Gives me 0.722. So it says 6I is equal to 0.7222. Then if I need I simply divide this figure by 6. So I'm dividing that by 6 in my calculator. That gives me 0.12, which 1204, which if I then multiply by 100% to convert it to a percentage, it gives me 12.04%. So that is basically our depreciation rate in this situation of straight line depreciation. So we are going to repeat the same exercise with reducing balance depreciation. All we need to do is capture the correct formula for reducing balance depreciation, which is A equal to P in bracket 1 minus I, all this to the power N. Our figures stay the same, 5,000 here, 18,000 the other side, in bracket 1 minus I. Our number of years, we've done the calculation already. In the first part it was 6 years. Then again, I will divide both sides by 18,000, which I have done the job yet already. So 5,000 divided by 18,000 gave me 0.27778. There were sums recurring, you can capture as many of them as you want. Is equal to 1 minus I, all this to the power 6. So at this stage, I need to take care of the 6. So I need the 6th root of both sides. So the 6th root means I'm taking the 6th root of 0.2778, and if I take the 6th root of this side, it gives me 1 minus I. Don't forget the 6th root is the same thing as raising this number to the power 1/6, and we do the same thing to this side, because if you multiply this by 1/6, you see it takes care of that 6. So if you don't know how to put the 6th root in your calculator, you can simply capture this as 0.2778 to the power 1/6. It's going to do the same job for you. So I'm going to do that. So luckily I know how to get the 6th root in my calculator, but as I've explained, if you don't know that, you know what to do. You just need to call it 1/6. So I'm getting 0.27778 bracket. I can even choose to raise it to the power 1/6. That will give me 0.80776 is equal to 1 minus I. So we need I to be positive, so I must cross over. Why this one crosses to the left, so I'll get I as 1 minus 0.80776. So if you do that simple subtraction, it gives you I as 0.1922, which if you choose to multiply now by 100% to convert it into a percentage, it gives us the depreciation rate as 19.22%. So, ladies and gentlemen, thank you very much. That's how easy it is to get these calculations that involve depreciation by straight line method as well as reducing balance method. Thank you very much.